today, what we're gonna do is we got two constructed responses today. Usually the constructed responses are pretty short. You can go ahead and pull them up and kind of get started on it. I would say do the water cycle constructed response first, because I'm gonna go through it a little bit here together with you on the board. So this one just asked about just the water cycle, or the hydro cycle, the hydrosphere. But it asks about the water cycle a little bit. It has an image that kind of goes through the hydrologic cycle in general, has a little bit of information for you in this chart. And then you'll have to use the actual reading to go through the questions. It's 10 questions, but they should be pretty short to answer. It shouldn't be real long answers for each of these. So the other one only has like 2 questions. It should be really quick and easy. So we can go ahead and get both of them done. So let me go back up to the reading, and I'll actually go ahead and assign the reading if you want to. You should need it to answer the questions, so this will help you get to the reading a little bit faster. I'll do the hydrologic cycle or the water cycle one first. That's what I'm going to do with y'all real quick. Today, or the space. Come on. I'm not going to do it. There you go. Actually, let me make this a couple more days. Okay, so where are we at? So this is the constructed response, Earth spheres, the water cycle. There's another one that's just Earth spheres. It's a lot shorter. You should be able to kind of do that on your own. But we might look at it before we get done. So question number 1, which part of the water cycle has the shortest residence time and why? Average time water spends in the reservoir. Here is going to be your residence time. Which one has the shortest one? Atmosphere. Yeah, atmosphere, because it's not going to stay up there very long. It gets evaporated, and then very quickly it's going to form a cloud, condense, and end up raining. And so while some moisture in the atmosphere can last in the atmosphere longer than that time frame of 9 days, that's just an average. It usually doesn't stay up there for prolonged periods of time. Like if you think about the water that stays in a lake or in the ocean, it's going to stay in those for very, very long times, or even groundwater too. Yeah, I guess the longest one's going to be the deep groundwater at 10,000 years. So it should be the atmosphere. Number 2, when rain or snow fall on land, where does it go? So if rain or snow falls on land, where's it going to go? Huh? Like a lake well, think more general. Like, yeah, it could go in the lake. It could go in the ocean. Depends on where it falls. Like the lowest place. Yes, it's going to go downhill. That's the most important part. It's going to go downhill eventually. Now, whether it ends up in a river, a stream, which will flow either into a lake or an ocean, it's always going to be headed downhill due to gravity. You could throw in lakes and oceans in there, or like the eventual stopping point. Ultimately, the ocean is the eventual stopping point, because essentially with every single lake, if you get enough rain, it's going to overflow its banks, and you're going to end up continuing your path down towards the ocean. So the ocean is the ultimate stopping point for all water. What is the location of most of the water in the water cycle? Where's most of the water at? In the oceans. The oceans are going to hold the most water. It's like, what was it? We saw it yesterday in there. It was like 96% or something like that. Let me go back. Yeah, it was a lot. Earth spheres, geosphere, geothermal gradient, hydrosphere. They talk about salinity.
Wait, I think it was
biosphere. Did I pass it already?
I think it said like
saltwater. Here we go. Yeah, 97%. Boom, 5 points. Let's see. Oh, I guess it didn't pull up. So yeah, most of the water in the water cycle is in the oceans. Where's the water cycle? Where in the water cycle is surface fresh water found? Lake. Yeah, that's going to be in your rivers and your lakes. Your surface freshwater is going to be found in your rivers and your lakes. And what's one more place you can find surface freshwater?
Glacier.
Yeah, in your ice, either glaciers on mountaintops or snowfall. That's going to be fresh water that's at the surface. It's not in liquid form, but technically it's still water. Why is residence time in rivers so low?
Because rivers are continuously running.
Yeah, they're always flowing. And so it's not going to take you very long to get to the lake or get to the ocean. If you have some longer rivers, you might spend a little bit more time in there, but it's going to be pretty low. So only 1 to 6 months for time spent in rivers on average. Yes, because they're constantly flowing. Perfect. What is transpiration? Anybody know what transpiration is?
Is that like evaporation while it's still running?
I'm going to look this up, but it is a type of evaporation, and I believe it's evaporation from plants. So, like when plants transpire, was that what you were about to say? Yeah. When plants release moisture into the air, that actually, we don't have a lot of that around here, but it does contribute to the atmospheric water content. And so if we come back over here, I don't even know if they would talk about that in the reading. Fresh water, streams, rivers, ponds, groundwater, the atmosphere. Yeah, they may not even talk about transpiration. Well, the biosphere. Nah, I don't know that they do. But yes, that is what transpiration is. How is groundwater recharged? So, like, if your groundwater gets low, how does it get filled back up? Yeah, rain soaks in, and the term they use is infiltration. Rain infiltrates the ground. It's like you're going into battle. But yeah, infiltration of rainwater into the subsurface is how groundwater is recharged. Put your mask up, Tim.
Infiltration of what?
Infiltration of rainwater into the ground. It's like soaking it in. Number 8. Why is deep groundwater sometimes referred to as fossil water?
It's been there for a long time.
Yeah, because it's been there for like on the time it has up here, it's been up there for like 10,000 or down there for like 10,000 years on average. And so yes, it stays deep in the ground for a very long time. That being said, has anyone ever heard of it referred to as fossil water? No. So I don't know how true that is. Maybe they heard it somewhere and they're like, I'll make a question out of it. Maybe it is true. Maybe all the groundwater people talk about fossil water all the time.
Yeah, they're trying to start people using that, so they put it in there.
What?
More people that use it.
Yeah. They're gonna open a company called Fossil Water and try to sell it for like $15 a bottle.
No.
Explain why the residence time in mountain glaciers is less than the residence time in glaciers in polar regions. So what's the difference between a mountain glacier and a glacier at the poles?
It's colder.
The poles are going to stay colder all year long, where mountain glaciers are going to be able to melt more frequently, and so you're going to have more runoff, and that water is going to be reintroduced back into the water cycle. So for mountain glaciers, they have about 20 to 200 years. For polar glaciers, they have about 20,000 years. So that one is actually the highest, higher than deep groundwater. And then number 10, as the climate warms, glaciers begin to melt. What impact will this have on other freshwater sources? As the climate warms, glaciers begin to melt. What impact will this have on other freshwater sources? If the glaciers are on land, that runoff is going to contribute to your streams and your lakes and your groundwater. If they're not on land, it's not really going to change your freshwater sources. It's actually going to reduce them because your glaciers are going to go into the ocean and mix with the salt water. But if they're on land, that runoff, the melt runoff, will contribute to lakes and streams and other freshwater sources, groundwater. Nice. So Tanner, 8th period yesterday. Why is my 8th period class having a discussion on whether or not you'll be the next Jesse James?
I have no idea. This is the first I'm hearing about.
It's really weird. I didn't like join in. I didn't know, like, are you building motorcycles, or do you have plans on like opening a motorcycle shop?
No.
Were they referring to like the old school Jesse
I
James,
have no
like an
idea.
actual outlaw? I don't know.
I mean, me and my brother ride Harleys, but I don't know anything besides that.
Yeah, I don't know.
I'm confused.
It was weird. I was confused by it as well. It's like, what's up with this conversation? So the next one should be pretty easy. It's only 2 questions. So if you have any questions on that one, let me know. I will help you out.
Oh, it's 10.
What? Hold on. Yeah, we went over these. So 9 was where are we at? 9. What's the difference between mountain glaciers and polar glaciers? What's the difference between a mountain and like the North Pole, the South Pole?
Polar, they're like always cold, and then the mountains are one time a year.
Yeah. The polar regions are going to stay cold all the time. The mountain regions during the summer are going to have a chance to melt, and you're going to have more recycling of water. Those glaciers are going to melt more often. Number 10, as the climate warms, glaciers begin to melt. What impact will this have on other freshwater sources? That glacier melt, if it's on land, the glacier melt will run down and contribute to the streams, the lakes, and the groundwater, and help to replenish those freshwater sources. Evaluate. And all right, so this one, I'm probably going to let you explore this one on your own. I'm going to read the second one and see what that's about. Number 1, describe 5 of the spheres. Be sure to identify which parts of each sphere, which parts of Earth each sphere consists of. So just give me 5 of the spheres. You have like the biosphere, the hydrosphere, the geosphere, and tell me what type of parts of the Earth fill up that sphere. So like an example, the geosphere is all the rocks on Earth. All the rocks on Earth are going to be the geosphere. And then just scroll through the reading, which I have assigned the reading. So you should be able to go and open that up on the Explore tab. And it has all the different spheres, and you can just go down and find 5 of them and give me a brief description of what's in there. So you have the hydrosphere, you have the biosphere, the cryosphere, the atmosphere, the magnetosphere, all of the different spheres. Give me 5 of them, give me a definition of what they are, and you should be good for that one. And then number 2, the Earth can be divided into a variety of different spheres that together encompass all matter and energy on the planet. Describe the role of the geothermal gradient in the appropriate sphere. Describe the role of freshwater and saltwater in the appropriate sphere. Describe the role of Earth's magnetic field and solar wind, creating the appropriate sphere. Describe 2 distinct ways in which the biosphere influences or is influenced by other spheres. So some quick examples. You're going to have to read to get to these. It's not too difficult. So describe the role of the geothermal gradient. If you go back to the reading, the geothermal gradient is up near the top. And basically they're talking about the heat as you go down into the Earth's surface. So the further down you go, the hotter it gets. That's going to create cold, solid rocks at the surface and melted rocks the further down you go. So that helps affect the geosphere by giving us solid rocks to the surface and then melted rocks like magma that can create volcanoes and other things like plate tectonics. So a little bit about the geothermal gradient and how it affects the geosphere. What was the other one? Describe the role of freshwater and saltwater in the appropriate sphere. Maybe tell me that saltwater is like 97% of all water, or was that the oceans? The oceans were 97% of all water, which is still all the oceans are going to be saltwater, and the rest is pretty much going to be freshwater. So only 3% of the Earth's water is freshwater, and that creates the hydrosphere. Describe the role of Earth's magnetic field and solar wind in creating the appropriate sphere. So we talked about the magnetic field. That's going to be towards the bottom. Oh, wait, that's not it. Yeah, it is. Further down here. The magnetic field down here in the magnetosphere. This is created from the inner parts of the Earth, the iron and nickel in the core, swirling around each other, create this magnetic field. And this protects us from the sun's really bad radioactive energy. It lets the light in, but not the radiation the sun puts off. And then what was the last one? Describe the two distinct layers in which two distinct ways in which the biosphere influences or is influenced by other spheres. So how is the biosphere influenced by other spheres? I mean, you could go simple. What do all living things in the biosphere need?
Water.
Yeah, we need water. So the hydrosphere is the biosphere is reliant on the hydrosphere. We all need fresh water to survive. Well, not really. All the ocean creatures live in the salt water. They don't need fresh water. And then what's another one? Trees and plants help break up the rocks of the surface and create soil, so that interacts with the geosphere. There's parts of the biosphere that rely on ice, so that would be the cryosphere. You could say that the magnetosphere protects all life on Earth from solar radiation and solar wind. So without the magnetosphere, the biosphere wouldn't exist. There's all sorts of ways. So just give me two ways that life on Earth is influenced by one of those other spheres. So number one should not be too hard. You might have to think a little bit about number two. Let me know if you have any questions, but it shouldn't be too bad. And we went through all of the stuff on the first one, so you should have the first assignment done. Turning the lights back on. If you have any questions or need any help, please let me know. I want everybody to get these done, because tomorrow we'll probably do an exploration.